All right, here is our second module for section 4. So module 4.2 is talking about constant rate of change. So I can identify, that means find, and represent a proportional relationship. But to be able to do that, we need to know what our constant rate of change is. So we learned in 4.1 about rates, right? So that's one of our first key terms is a rate of change. Again, that's a rate that describes how one quantity changes in relation to another quantity. So just another term for rates, it's the rate in which something changes. So a proportional relationship is a relationship between two quantities where the rate of change is constant. So that means that it will always be the same, right? It will not change. So a speed of a car would not be considered proportional because we know that it changes, right? But, you know, maybe a price of something doesn't change, or the amount you get paid per hour at work maybe doesn't change. So some things will be constant and some things won't. A proportion, just as a reminder, is a statement where we have two rates or two ratios, right, that are equivalent. So that's where we can say 1/2 is equal to 2/4, right? Those are both technically the same thing. And so that is why we would call them proportional. Make sure you pause, take time to copy those down. So to determine if a relationship is proportional, you find the unit rate by doing y's over x's. So y over x just means, just like on a graph, we have our y-axis and our x-axis, okay? In a table, it will always be, the first number will always be the x and the second number will always be the y. It's just how it is. And so it's so we all stay consistent. We have to check all of the rates, not just one or two, right? So it says Callie earns money by dog sitting. Based on the table, is this relationship between the amount Callie earns and the number of days a proportional relationship? So we're trying to find out, does she make the same amount the whole time, or does something change? So we actually have to check all of these. And what we're going to do is we're going to write all of these rates, writing them this way. So it's going to be 16/1. Well, that gets me 16, right? Then we'll do the next one, 32 divided by 2 or reduced. Well, thankfully, that will also get me 16/1, which was the same as the first one. So then we'll do the next one, 3, oh, not 3. See, even I almost messed it up. 48/3. We would need to reduce this. So that's 1 and 18, 16/1. And then we do the next one. And I know you're like, well, why are we checking all of these? Well, we have to. Just like in a car, maybe I've been driving for hours on end at 60 miles an hour, but I then had to slow down coming into a town or something. And so my rate would change. I have to check all of them over all of the time, not just the first couple that match. So then 4/1, that's 16 as well, over 1. And then we're going to check the last one, 80/5. Oh, that's 1. And that's 16/1. Okay, so we did get 16/1 on every single one. So we could say, yes, this is proportional, because you can see that all of my ratios, all of my unit rates, see how my denominators are 1? They all match, 16/1. And since they all match, we can say it's constant or say it's proportional. Same thing. So if a relationship is proportional, then we can write an equation that would help us find all of them because we've proven it's proportional. So we say it's y equals k, which stands for the constant of proportionality, right? That's the number that makes it proportional, and then times x. The only number we're going to actually have is this one, the k. The K is only going to be the one with the number. Y and X are going to just stay as variables. Okay, so this is going to stay as a variable. This is going to stay as a variable. And this one will be a number. So I'm actually going to go back. So if we think about Callie's situation, we got her constant was 16, right? That was her constant in Callie's situation. So we could write an equation for Callie and write y equals 16x. That's how we would write a constant of proportionality relationship and equation for Callie, our first problem. Okay, so now we'll go to the additional practice. This is your second page. It says the tables show the distance Allison drove on one day of her vacation. Is the relationship between the distance and the time a proportional relationship? Did she drive a constant speed? Explain. So again, this is always going to be x, this is always going to be y, and to find our constant, we're going to always do y's over x's. Okay, so now again, I have to check all of these. I can't just check one or two. So I'm going to go 65 over 1, right, because we go this way. Well, that's 65, and that's my unit rate. So then I'm going to do the next one, 120 over 2. Well, that's 6, and that's 0. So here's the thing. I actually can stop because I've actually already proven that she did not drive a constant speed. No constant speed. Not a proportional relationship. So as soon as you find unit rates that don't match, that's not constant. A constant has to have the same unit rate over and over and over again. So even if I check the next one, we can even see, it doesn't matter, but it's worth, just checking. So that would be 5, nope, 6, 18, and then 5. So then jumps back up. But because this one right here already doesn't match, it doesn't matter. It's not constant. Okay, I can check another one. 220 over 4. So that's going to be 5, right? 20. 6 would be 24, so it would be too much, and then it'd be 5 again. So actually, there's another one that doesn't match. So now I have 2 that make it not constant. But again, I figured that out by this one right here. The first 2 didn't match, so it doesn't matter. Okay, so I want you to pause and try this one. We're determining if this relationship between the cost of cashews and the number of pounds is proportional. If so, we're going to write an equation. Okay, so just don't forget this is x and this is y. And to find our unit rate or our constant, we always do y's over x's. So pause, try this one, take your time. You might actually have to do some division, especially for this one with the decimals. Okay, so first one, 19 over 2, that's 9 and 950. Okay, that's my first one. So then for my second one, I'm going to set it up 2850 over 3. Okay, that's this one. That also got me 950, right, if you did it. And then the last one, 76 over 8. You actually have to divide, right, because we're getting decimals. We also should have gotten 950. So since they all came out as 950, we can say that yes, this is a proportional relationship. Because 950, 950, 950, they all match. And since they all match, we can write an equation, and our equation should have been y equals 950x. Remember, variable, number, variable. So some things to remember: constant equals unit rate. That's from 4.1. Unit rate is going to be y's over x's. And then remember, in a table, I'll just kind of draw one. This one's always x, and this one's always y. Okay, so here's your independent practice. You're going to try this one, and we'll go over in class. This will be checked to make sure you're finishing your independent practice. Till next time.